Hello everyone, welcome to this video by Data Sense. So we will continue our course on Python libraries. In the previous video, we covered about the pandas, and now we are moving to one of the very important library, that is NumPy. Though it is important, plus to be honest, it's very simple library. It has just few basic concepts and few basic operations that you need to understand, and you will be very good to go. So I hope you are doing well and you are excited about this course. So let's continue about this discussion for NumPy library. Okay, so NumPy stands for, if you check its name, it is numerical Python. Okay, NumPy stands for numerical Python. So it's self-evident that this library is used for calculations. Okay, calculations mean taking the numbers, doing their operations and all that. So if you remember, pandas was all about the data analytics. Okay, taking the data frame, converting it to data frame or series and using various operations. This library is all about taking the numbers, converting them in a vector and doing the calculations. Okay, so what it does is that basically it takes any set of numbers. For example, let's say 1 2 3 4 5. The major thing is that what it does, it converts them into an ND array and n dimensional array. Okay, or you can, it is a vector. So I'm not sure if those who have some experience about in science background, they would know what is a scalar, what is a vector. But if you don't have, don't worry about that. We will study about all the properties. So how it works is that it takes so n dimensional array, so it can take the numbers. So what is a 1D array? It can either convert them into a 1D array just like this. Okay, 1 2 3 4 5. Remember, this particular thing is not list. Okay, I will explain that as we move ahead, but it might look like list, but it is not list. This is a 1D array. Okay, so the array and list, they are different data structures. Okay, 2D. So what you can do, basically 2 by 2 matrix. So you can do 1 2 3. So let's say 4 5 6. So it becomes 2 by 3 matrix. Sorry, right? So similarly, you can scale it up to any particular level of matrix. So this is all that NumPy does, that it converts the number into arrays or vectors, and you can perform operations on them. Okay, so how is this different from list? That is something you want to understand. That if you remember lists, for example, what happens in list, that you can store any type of, you can store 1, you can store A, you can store 3, then you can again store D. So you can store character and numbers in the same list. But in vectors, or you say NumPy, you can only store one type of data type in a single array or something. And this is the reason it takes less space. Okay, and it is more efficient for calculation. Okay, more efficient for calculation. This is something, I mean, you should know that. If someone might ask that, okay, NumPy also converts in a 1D array, list is also 1D array. So how are they different? Different is that this particular thing takes up less space as compared to this. This is something you should know. And I think we will start with the Python. There is not too much to worry about. I mean, there are few basic concepts that you need to learn, few basic operations that, for example, let's say there is a list, right? If you do 1 2 3 4 5, if you add 1 to a list, it will not add to every element. But if you add in a array, what will be the result? 1 will get added to all of the element, 2 3 4 5. It will become like this. So this is how we will study about this particular array. So let's move to our assignment. So let's read about a little bit. So NumPy, numerical Python, is a core library in Python for numerical computing. Okay, it provides support for large n-dimensional arrays. We got it, along with a collection of mathematical functions that we will see. Okay, not a problem. Now NumPy is used, basically it allows you to perform efficient operation on large data set. So what it does, it takes the large data sets, it converts them into vector, and it just let them add, subtract, or whatever operation you need to do. So compared to Python list, NumPy consume less memory and provide better performance for mathematical operations. So as I said, lists take up more space. The NumPy array takes less space. Okay, so when to use NumPy? When you have we will see all those applications, don't need to worry about that. So let's straight away dive into the concept of n-dimensional array. So NumPy's core data structure is the ND array, which stands for n-dimensional array, as I showed. And ND array is a generalization of a matrix, and it can have any number of dimensions. Okay, so 2 by 2, 1 by 2, 3 by 3, it can take any, like you can increase the dimension. So we will move forward with creating our basic NumPy array. So a simple one-dimensional array, what we will be doing. So how it is done is that you simply import NumPy as NP. Okay, so like in pandas we used to do PD, here we do NP. Okay, so now we will create an object. Okay, so this is the class that we have taken. So now what we will do, let's say create a is equal to NP dot array. So we'll call a subclass under under NumPy class we will call another subclass, that is array, and we want to convert. So how it is done, that we will pass it as a list, for example 1 2 3 4 5. Okay, and now we close it, and now let's say run this. Okay, now let's print a. So if you see, we got 1 2 3 4 5. Now let's see the type of a. Type of a will not be a list. Okay, it will come out to be a ND array. So that is something you need to know. This is not a list anymore. Now for example, let's say I change it, like L is equal to 1 2 3 4. Okay, now here type of, let's do type of L. Okay, and let's, instead of passing this, just simply write down L. Okay, so if you see type of L is here. Now when I convert into NP array, how does it change? So type of L, right? So L was a list and it is converted into a NumPy ND array. So this is something that you need to know, how to create a basic NumPy array, you can say, from a simple list. So I'll just paste it here and I will just print type. Okay, so this is a one-dimensional array. Why? Because this is going like this. So now let's move to the assignment. Now how do we create a two-dimensional array? It is exactly same, just what you need to do that inside this. So for example, remember, we have to pass a bigger list like this. So how do we create a two-dimensional array? So very simple. So we'll do np dot array. Okay, in array, remember what we need to pass. We need to pass eventually a list. Okay, and now this list will be further list of, so because it is a multi-dimensional array, so we will have first row here, we will have second row here. Okay, so we'll pass like 1 2 3 and 4 5 6. So what it will result in a 1 2 3 4 5 6. It will result something like this. Okay, so this is what we are going to do. So np dot array and 1 2 3 comma 4 5 6. Okay, so now let's print. So we see that this is the first row, this is the second row. This is a two-dimensional NumPy 2D matrix. It is technically a matrix. So here we create 2D array, often referred to as matrix, right? So this matrix has 2 rows and 3 columns. So why it is called 2D array? Because it has 2 rows and 3 columns. Unlike Python, NumPy arrays can efficiently handle multi-dimensional data structure like matrices and tensors. So we'll see that later. But as I mentioned, these are more efficient as compared to anything else. So that is the main thing. Now let's come to the element-wise operation. As I told, you can take any array if you add, because it is a vector. So remember, the properties of vector is that whenever you add something to vector, it gets added to the whole I will say whole vector. So let's say this was 1 2 3 4. Okay, so let's say a is equal to this and b is equal to a plus 10. Okay, Now I print B. Let's see what it comes. So 10 got added to each of the element. So this is the basic property of a NumPy array. Now we'll see about the matrix multiplication, that is a dot product. So before moving to the matrix multiplication, let's look at one example which I just spoke about. For example, let's say we have a list L is equal to 1, 2, 3 and 4. Okay. Now let's say I want to add 1 to it. So let's say I do that P is equal to L plus 10. Okay. So what will happen? I am adding a list with an integer. If I directly add this thing, it will give me a error. Can only concatenate list, not, so basically it cannot add integer to a list. Now if you add, so see how it is different from the NumPy thing that we were doing. In NumPy, if we are adding thing to a vector, it is adding, like for example here, if I'm adding something to it, it is getting added, but with list it does not add. This is the difference, that NumPy array are vectors. This is not a vector, this is just a data structure, and it does not take integer, it does not take two data structure of different types. Now let us say I change this to list. Okay, so what will happen here? 10 got added to each of the element, but what will happen here is that, so let's say I print P. So what will happen is that 10 will be added as a next element in the list. So it will not be added individually to each list, rather than it will get added separately, right? So this is something that you should know, why lists are different from NumPy arrays. Now let's move to the dot product, right? So matrix dot product. So it's something you should know, even if you don't like. So for example, let us say I have a matrix A is equal to, so let's take a 2 by 2 matrix example. So this is A11, this is A12. By 1 means row number 1, column 1, row 1, column 2. Okay, and this becomes row 2, column 1, row 2, column 2. Okay, and let's say I have B. So B is equal to, so B11, okay, B row 1 column 2, B row 2 column 1, B row 2 column 2. Okay, so let's say I want to do a dot B, that is a matrix multiplication, A dot B. So what will happen is that it will result in a 2 by 2 matrix. Okay, so how is this going to add up? Okay, so let's see that. So first of all, there are 4 places to fill. Okay, this is the first place, this is the second place, this is the third place, this is the fourth place. So how it will, just see the logic, how it works. Okay, so it is important one. So A11 will multiply with B11, okay, and A12 will multiply with B21. So this will multiply with this, and this will multiply with this. So it will be A11 into B11 plus A12 into B21. This is a rule that row 1 column 1 will multiply with this one, and this will multiply with this one. Now similarly, if I have to get the second element, so this will multiply with B12, right? So it will be A11 B12 plus A12 B22. Okay, so this is how it is going to do. Now let's see this A21. So how it will go? A21 will multiply with B11. Okay, so it will be A21 will multiply with B11. Okay, plus, okay, so A21 will multiply with this, and A22 will multiply with your B21. Okay, so A22 will multiply with your B21. And how this will happen is that, so A21 will multiply with your B12, okay, and your A22 will multiply with your B22. So this is how matrix multiplication is done. I know it might sound confusing if you have not, so like this is something that is taught in I think 10th or 11th class, but if you don't know that, don't worry about that. I mean, in Python you can do it directly, but you should know the logic. So let's look at a couple of example. Okay, so let's do one thing. Let's go to our question. So we have a dot product 1 2 3 4. Okay, let's say there is a matrix 1 2 3 4. So A is equal to 1 2 3 4. Okay, and B is equal to, so let's look at the other matrix 5 6 7 8. Okay, so P is equal to 5 6 7 8. Okay, now let's say I want to calculate A dot B, that is a product of these two matrices. So let's hold on some space. So how it is going to look like? So as I mentioned that A11 will multiply with, so 1 will multiply with 5 plus 2 will multiply with, so 2 will multiply with your 7. Okay, so 2 into 7, so it becomes 5 plus 14, so this will become 19. Okay, now we will see this one. So 1 will multiply with 6 and 2 with 8, so it will be 6. So 1 with 6 plus 2 into 8, so it will become 6 plus 8 to 16 plus 6 22. Okay, so it will become this matrix. Now it will become 15 plus 28, so it will become 43, and it will become 18 plus 4 8 ja 32, so it will become 50. So the resultant matrix will be 19 22 43 and 50 if you multiply these two matrices together. Okay, now let's see how things are done in Python. Okay, so for example, let's say I have these two matrices here. Now I take the first matrix just like this and second matrix. So I take np dot and I just multiply. So let me show you how to write down this in Python. So for example, we will go here. Now matrix underscore A. Okay, this is equal to np dot array. Okay, now what we need to do, we need to pass a list inside. Now inside this list we will have two lists. So first will be 1 2 and then second will be 3 4. Okay, so this will become your first matrix. Now similarly, let's copy this and let's change the numbers. So matrix B will be, so 5 6 7 and 8. Okay, so now I'll do prod, so it is equal to dot, so it will be np dot, right? So how we do, np dot means dot product. Okay, so np dot and you provide matrix A with matrix B. Now print prod. So we got 19 22 43 50. This is something that we got here in this case. So this is how matrix multiplication is done. Let's see if our result changes if we change the order of matrix. So let's see this. Right, so your product will change depending upon what is first, what is second. So A into B is equal to B into C into B into A. So basically A into B is not equal to B into A in matrix. Just remember this thing. Okay, so the order of matrix in multiplication matters, and this is what you should remember. Okay, I hope this is clear. This was simple part. So the matrix multiplication. Now we will move to array reshaping. So let us look at reshaping an array. So for example, there are two types of reshaping possible. The first is, for example, you have a 1D array, let's say. So 1 2 3 4 5 6. Okay, let's say you have this thing available. So you want to break it into a 2D array. So you want to convert a 1D into a 2D array. So what will it become? It will become 1 2 3 4 5 6. You want something like this. One is this thing, you convert a 1D into 2D, and second is converting a 2D array into a 1D array. So reverse of this, 4 5 6 into flattening. So this is called flattening an array. Okay, flattening. basically higher dimension to lower dimension. 1, so 2, 3, 4, 5, 6. There are simple straightforward things for this, but yeah, there are, like, if you do data structure and algorithms, there's a good algorithm to do that we will cover in our DSA course. I think we did a question like this in one of our DSA assignment as well in the Python basic course, but yeah, I mean, it's fine, we will do that later. But in NumPy you have a straight function, you don't even need to do anything. It's pretty simple. So what you need to do is, for example, let us say you create a NumPy array. For example, let's say array, let's name it p is equal to np dot array, okay, 1 2 3 4 5 6. Okay, so you have this particular array. Now what you want to do, you want to convert this into a two-dimensional array. So you will use, there is a word called reshape, and then you provide the dimension which you want. So for example, you use array dot reshape, and then you provide the dimension in which you want to do. For example, let's say z is equal, or you can say z is equal to p, which is your array dot reshape, okay, and then you provide the dimension. So for example, I want to split into 2 by 3, two rows and 3 columns, and now I print z. Okay, so it has converted into this part. Now let's say I want to convert it into 3 by 2. So what it will become? It will become 3 rows and 2 columns. So let us say I want to convert it into 6 by 1. So it will convert into 6 small arrays like this, something like this. Okay, and let's say if I do something out of the list, for example, let's say I do 3 by 4, which is practically not possible. So it will say that array cannot shape 6 into 3 by 4. So this is how it is done, how you convert a single single dimensional array into a multiple. And just the reverse of it, for example, let's say you want, so let's say you have an array is equal to np dot array, and what you do, so how to write, first close this, there should be a bracket inside it. Now inside this there should be value. So 1 is 1 2 3, okay, and second is 4 5 and 6. So let's say this is your value. So what you will do is closing parenthesis, okay, just a second, so does not match. So this is matching with this one. Okay, yeah, I need to match this one, right? So this is my 2D array. Now if I print this, print p, I'll get a 2D array. Now what I will do, so d is equal to p dot flatten, okay, and print d. So what it does, flatten keyword, it just converts this particular matrix into a one-dimensional format. Okay, so this is how things are done. So this is a pretty straightforward thing. I mean, there's no rocket science, but it will be used a lot of times. So the flatten method converts a multi-dimensional array into a one-dimensional array, right? This is the reverse of reshaping. And like, for example, there will be many applications of this once you do DSA, not in DSA, but for example, when you do data engineering codes or data science ML codes, then also this thing comes a lot. So these are there. Now let's come up with the slicing. I think you all are very familiar with this one. I'll just give a refresher. So let's say you have this array and you want to get first to 4, 1, so second, third, fourth element. So you will do 1. So it will take this 2, 3, right? And it will, so 20, 30, 40. So single array slicing is done this way. Now let's discuss about, I just discussed about the 2D slicing as well, but still let me show you how 2D slicing is done once again. So let's say we have an array 1, 2, 3, 4, 5, 6, and 7, 8, 9. Okay. So let's say we have array 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, whenever you do slicing, this is first part is for row and after comma second part is for columns. Okay, and if you remember, row itself is a like single dimensional list, you can say, and column is also a single dimensional list. So you will do slicing keeping this thing in mind. Now for example, let us say let's check our question. It says this thing. So let's do, okay, so for example, let us say I want row number up to 2. So for example, from 0 to I want first 2 rows, right? So what I will do, L, okay, 0 to 2. So what is it going to mean? That my row 1 and row 2 will be selected. Now I want to filter on column. Let's say I want column 2 and column 3. So what I will do, 1, 2, 3. Okay, so let's see what this slicing. So this slicing will eventually result in 2, 3, 5, 6. Okay, this is how it is going to do. The first part does the rows slicing, second part does the column slicing. So now let's see what does this do. 0 to 2. So this means it will get you the first 2 rows, and what is the second part? 1 to 3. As I mentioned, it is going to give you second 2 columns. So let's run it and let's see what are we going to get it. 2, 3, 5, 6, that we got it here. So this is how we just discussed in the pandas as well, that how to do slicing in a 2D when you have a 2D matrix, right? So that thing you can do. Now let's see if you have to filter any array. So it's again a pretty simple thing. If you see, you have taken an array like here, and you want to filter those array where value is greater than 25. So as simple as that, you just pass array greater than. So let me do that. So let's say p is equal to np dot array. Okay, and let's say we have 20, 30, 35, 38, 50, 51. Let's say we have these many values present. Okay, so now what I want is that okay, I want to filter those. P is equal to, so Z is equal to P. Okay, and where you can say P is greater than 30. Now if you print Z, so you got 35, 38, 50, 51, right? So you just took Z and you just passed it should be greater than 30. So it will simply result in those values which are greater than a particular value. So these were the basic operations on a like using NumPy array. Now we will move to some mathematical operations. So we will continue our discussion and we will move to the next important part, that is mathematical functions. Now mathematical functions are very important when it comes to NumPy, and these are very simple ones. There are some standard keywords that you need to know, and you just need to pass them to your respective array. Okay, so what are we going to do? First of all is, let's say we have to use sum and mean. So let's create a basic array, for example. So let's say this is an array is equal to np dot array, and let's create 1, 2, 3, 4, 5, 6, 7. Okay, so I created this basic array. Now what I will do, I'll do sum is equal to np dot sum of n, this object that I created. Okay, so I just need to pass that and it will give me. Now if I do a print of sum, it will give me the sum of all the elements that are present inside this. And now let us say I do mean. So for example, I just change this sum to mean. It will give me the average of these values. So it's pretty straightforward. I mean, there is no like big understanding. They're just keywords. You need to know how to, the basic difference which lies is how to use them, because as I mentioned again and again, it is not very intuitive like SQL, so you need to sometimes learn it. But most of the time, see, if you know the concept, if you know which function to use, you can any ways like use ChatGPT to get it done. Okay, as I say here, if you use ChatGPT at your work, no one is going to say you anything, and it is pretty obvious. No one can remember all these many things. It's very obvious, but you should know what type of functionality each library offers to me and what thing can I use. So whenever you for example face trouble, whenever you get stuck somewhere, you should remember which library to use. Okay, this library might have a function like this where I can add elements, right? So if you are okay with, if you can understand this much, you are very good to go. So now we will do, there are some basic, like if you see maximum and minimum, like I don't want to spend too much time on this. It is very simple. For example, let's say you created an array like this and you did np.max of this and max minimum of this, so you will get the maximum and the minimum value. So it's a pretty simple word. Now coming to the next part, that is dot product. We did it just now only. So 1 2 3 4, remember, if we have to take a dot product of 1 2 3 4, what will happen? 1 2 3 4. So what will happen? 1 into 3, that is 3, and 4 to 8, right? So and if you have to just sum them, it will become 11. So that is a big dot product. And now if you do a multiplication, right, this is something that we just did, 1 2 3 4 5 6 7 8. So this result we got it at top as well. Now let's move to the last part, that is random generation of numbers. So random generation, if you know, there's a probably like a normal distribution, if you know, like still if you don't know, I mean, it's fine. You need to have some statistics that, for example, let's say you do not know that you want to generate some random numbers for your case study, or you want to test something. So it can produce some numbers which are normally distributed. So normal distribution means that 95% of the values lie inside this confidence interval, right? And this is something, I mean, if you don't know, you'll get confused, but it's fine. I don't want to spend time on this. Just understand it produces some random numbers which are uniformly distributed. Okay, so just understand this much for now. When you do statistics, you can refer to that. So so this is called a uniform distribution. So what we do, that np.random.rand 3 by 3. So what it will do, it will create a random matrix of 3 by 3 rows, 3 columns. Okay, this is this. And again, you can generate a normal distribution depending upon how you want. So this was a uniform distribution, this was a random normal distribution. So there's basic difference between these two. One is standard normal distribution and one is uniform distribution between 0 and 1. So it's fine. I mean, you can understand it, not a very big deal. So that's how we will finish with the NumPy. Now you have few assignments, basic assignments, which you can do. So like create a 1D NumPy array, create a 3 by 3 matrix, then you generate numbers randomly, and you do calculate few things, right? So this much you can do on your own. And if you face any doubt, you can just comment on this video, or you can just like reach out to us on WhatsApp. As I mentioned, if you don't remember these functions, that's totally fine, but you should know these are the functionalities that are present in NumPy, because we will be using them extensively. At least how to create an array, how to do some array, like let's say array addition, array multiplication, array adding an element to array. So those kind of things you should know, and that's more than enough. So again, thanks a lot for watching this video. Next we will cover matplotlib and seaborn. So this course has just started. We have a long way to go. I'm just setting up the basics, right? Because once we start data exploratory part, then these things will become very handy. So that's why I have explained all this in detail. So it's fine, just try to do this. They're not very complicated, so just finish them as soon as possible. And I see you in the next video, and please subscribe to our channel. Thanks a lot.